And we are recording now. Yay! All right, so I can solve equations and inequalities to reason with real world problems. That's the second part to our learning target. It's not just solving equations, it's also inequalities. So that's the part that we're taking care of with this part. Write your name, not mine. This is my name. It's fifth period. Your test date is 9/17/25, which is a yep. All right, so I have your learning target at the very top there. Okay. I can solve an inequality involving the multiplication or division of a negative number. I can show the solution to an inequality on a number line. And I can express a solution set of an inequality in interval notation. Now, here's the problem that most of my students have with inequalities. They think that there's only one answer. But inequalities are solution sets. It's a big set of answers. It can be half of a number line. That goes on for infinitely. Or it could be a middle section or the other half. So you have to figure out which part of the number line it actually falls under when you look at the answers or solution possibilities. So choose the correct sign between the values. Between -5 and 5, should it be -5 is less than or -5 is greater than? Hiba. Less than, thank you. Here we go. Let me change it to red. Less than. Okay. Is absolute value of -7 less than or greater than or equal to 7? Thanks for raising your hand. Oh, yes, Monica. Equal to 7. Thank you. 5 is less than or greater than or equal to -5. Thank you, Brian. Greater than. Good job. All right, so when we say these, we're literally just comparing answers, right? When we talk about it with when we talk about it with variables, we're looking at a big half of the number line where the 5 or 7 or 8, whatever number value is my boundary, okay? It's my cutting point where half of the number line is going to be counted in the solution versus the other half not being counted, okay? So meaning this. If I say x is greater than 2, what numbers are greater than 2? Pepe. 3, 7, 8, 9. So is it to the right side of 2 or left side of 2? It's the right side. When we have greater than, that means that it's a boundary that is not included. So when it's not included, we use an open circle. And we say everything to the right of that counts as my solution set. Okay? Does that make sense? Yeah. So how many answers do we have? Infinitely many. To be kind of exact, half of infinity. Because it's the positive half from 2. Does that make sense? Yes? Okay. All right, so this one is different because it has a half equal sign right there. This means it's less than or equal to. So instead of writing 2 lines underneath it, mathematicians thought, too lazy. Let's just make it half. Because it's not totally equal to, it's equal to and more. Whether it be less than or greater than, but there's more possibilities for x's to be less than or equal to 2. So x can equal to 2 is an option. Before, was x equal to 2 an option here in the first one? Nope. X could not equal to 2, right? So that's why it's an open circle on 2. In this case, because we can include it, if it's an equal sign, you would put a closed dot on it. But because it's an inequality, we're going to talk about all the parts that are less than 2 as well. What numbers are less than 2? 1. -15? -15? Any negative numbers? Yeah? 0? Yep, those are all possible numbers that we can count as a solution for this one, right? This is 1.3. Do you guys remember how to graph these? Yes? No? Then learn it today. Learn it today and hold on to it so you don't forget, okay? Because you're going to use this in Algebra 1, Geometry, Algebra 2, Calculus, Trigonometry, and probably Statistics. So I need you to know these, okay? All right, so 2 is less than x. If 2 is less than the unknown numbers, the possible solutions, where should the x's be? Should the x's be to the right of 2 or to the left of 2? 2 is less than x. Pei? If 2 is less than x, then it's going to be to the right of 2. And this should be an open circle on 2. Why is it an open circle, not an equal, like a closed circle?
Because a closed circle includes 2.
Closed circle includes 2. So I have this inequality anchor chart right here for you guys. So this is everything you're going to be learning this part of the lesson, the notes. We're talking about greater than or less than. The signs without the equal sign are all open circles. Signs that have less than or equal to or greater than or equal to, so it includes a half equal sign. It's always with closed dots, closed circles, okay? These are called interval notations. This is the 1.4 part of your notes, okay? We're going to show how this relates to these as we go through it. I don't think we're getting to compound, but I could be wrong. But compound for sure, we're including it in Algebra 2. So let's see. Need to know number 2. When is a closed point used on a number line? We just answered it. When is a closed point used on a number line?
When the value is equal to the
Okay, how about when the inequality, because that's the inequality expression, right? When the inequality includes or is equal to the value of, I don't know, value of x? No, value of boundary? Which one makes more sense to you? When the inequality, that includes the x, right? Inequality is talking about the solutions. So that's the x, the value of the boundary. Bless you, are you okay? Is something there that's bothering you?
No.
Are you sure?
Yeah.
I mean, I have the air purifier right next to you. But if you need something, let me know. Okay. I can't give you any medicine, but I could help you with positions in the classroom. Okay. Or maybe you're just allergic to math. Open point. Open point. What does an open point mean? When I say boundary, do you know what I'm talking about? The number. The number that the inequality is set against, I guess. If it's like inequality is x is greater than 2, the 2 is the boundary. Okay? If I have x is less than -5, then the boundary is -5. The number that the inequality x is less than is set equal to. Does that make sense? Set unequal to or equal to set against. Okay, so when do we have an open point? When do we have an open point? Go for it.
When the value cannot, when the inequality cannot, sorry.
It's okay. It's confusing. An open point show. What does it show?
When the inequality cannot equal to the value of boundary.
Inequality does not include. So I often say exclude, so I'm putting it in here, okay? Does not include means same thing as exclude. The value of the boundary. Does that make sense now that I explained boundary? Yes or no?
Yes.
You guys, I really need you guys to be on it with me because your test scores were not very good. We also need to show our solution using interval notation. Interval notations, if you use less than or greater than, you're going to use parentheses. Okay? If you have greater than or less than or greater than, but also half equal to, less than or equal to, greater than or equal to, you use brackets. Squared parentheses like this, brackets. Parentheses rounded, brackets closed, okay? So, for example, let me do an example of if x is greater than 2, right? What numbers are greater than 2? What else? What else?
5.
So is that to the positive direction of the infinity or negative direction of the infinity? It's infinite, right? But which direction is it? The positive direction or the negative direction? The positive. So this is how we write it. We start with 2 and we put parentheses because it doesn't include it. And because positive infinity is a direction, is there a final destination to my infinite numbers? If there is no end point, then you use open. Infinities always get open. This is an interval notation. I use this all the time in Algebra 2. All the time. I need you to make sure you know how to do that. Okay? All right, so let's say I have x is less than or equal to 2. How do we show that? Which numbers are less than or equal to 2? Is it the positive infinity direction or the negative infinity direction? Negative. So we start with the less value, okay? We put negative infinity first, and it's directional, so we use parentheses, and then we put 2 to include. Okay? This is an inequality. This is an inequality. And this is, what is it called? Interval notation. Okay. Which learning target is that? 1.4. Okay. All right, questions? Okie dokie. I'm really worried about you guys. You guys are amazing about getting things done, but I worry that you guys were doing it incorrectly because there was a lot of little mistakes that led to a lot of big mistakes. So please, if something's not clear, please ask. Please ask. Okay? We also need to show our solution using interval notation. So let's see. Wait, is that it? Okay. So how do we solve and graph this? Let's see. If I have x plus 1 is greater than 2, you treat it just like an equation. But you keep the inequality sign. Okay? I hope you understood that. So what's my very first step here? Let's see. How should I treat? I need you to take this and set it. I'm going to pick someone. So hang tight. I need you to treat this and think this. X plus 1 equals 2. But you're keeping this guy at the end. Does that make sense? Okay. So you're treating it like an equation. You solve it like an equation, but you need to keep the inequality sign because your answer is not going to give you one solution. It's going to give you half of an infinity. Okay? Does that make sense? A little bit? Okay. Let's see. Can I get... I hope I get the name right. Christian Nava. Nava, not Vong.
Okay. Wait.
How do I solve for x?
For x.
Uh-huh.
So you're gonna do -1.
Yep.
And -1 on the other side.
Perfect. Good job.
You get 1.
Yep. But we're not going to put an equal sign. We're going to keep the exact same sign right in here. So we're going to do x is greater than 1. Okay, I read it the way that it's supposed to be read. X is greater than 1. So here's 1. Do I put an open or closed circle? Open circle. Oh, not on 2. It should be on 1. And which side is greater than 1? Which side is greater than 1? Is it to the right side? I just threw. That side? Right side or the left side of 1?
Right side.
Right side is greater. The numbers keep getting bigger and bigger towards the right. Okay. Any questions? Clarification? Comments? This is the easy stuff. So if you're getting it, great. If you start getting lost, don't sit there and wonder if it's going to hit you later. It's not. So I need you to ask me, okay? It's not going to hit you like a brick wall later. It's just going to stop you. You can't go through it. All right? Okay, let's try this one. Number 8. Number 8. Okay, so we're going to think that this is an equal sign. So x minus 1 is less than or equal to 2. I'm going to think this as an equal sign. So I'm going to erase it temporarily. And go back to this. Equals 2. Now, how would we solve for that one? Let's see. Jake.
So you would add 1 on both sides.
Bingo. Here we go. Plus 1. Plus 1. Then I have x is equal to 3. If x is equal to 3, I just need to bring the same sign back into the picture right here and rewrite it. So it should be x is less than or equal to 3. Is this an open or closed dot? Closed. So I'm going to put closed dot on 3. And which side are my numbers less than 3? Towards the negative or towards the positive? Towards the negative. So I'm going to go this direction. Okay? If you have a highlighter, feel free to use that wonderful colored highlighter to highlight this section instead. Okay? I really don't care how you shade or highlight to show your solutions. If you want to use a highlighter, I will use it to demonstrate. Just go like this, like that. Boom, done. Okay? Any questions? Are you sure? You guys are really sweet. I was talking with Miss Anthony, and we were both agreeing. The entire 8th grade class is like the sweetest class I've ever had. We just need you to ask more questions. That's all. Okay. All right. So again, number 9, we have 3x is less than 6. Is the x isolated yet? No. So we need to isolate it. So we need to think. Sorry, I'm using a highlighter. I'll go back to a pen. Okay. Think. We're going to do 3x equals 6. So how do we solve that? Let's see. Charlie.
We divide?
Yep. Oh, by the way, on your test, there were so many people who did this. I'm not kidding. It was like more than half the class. Yeah. That's why I'm like, ask questions, please. Yeah, you're going to get it back today. As long as Brooklyn can finish. Oops, that was an eraser. My bad. Okay, we're going to divide 3x by 3 and we get a whole 1, right? Do you see the giant 1 there? Kind of funky, but it's giant 1. Yeah? let me see if I could fix that. Oops, 3. I'm gonna move this 3 to there. And then, I don't know about your 6th grade and 7th grade teachers, but I always taught it this way. If you can make a giant 1, they simplify to 1, right? 3 over 3, make a giant 1. So you could just write 1. In this case, we don't need to write a 1, we just write x, and we already know what that means. It means 1x. 6 divided by 3 is 2. So is it equal sign or is it a different sign?
Less than.
Less than sign. So I need to make sure it's showing this, not the equal sign, okay? So what numbers are, oh, open or closed? Raise your hand. Open or closed? Mia, open. So it's gonna be an open dot. So I'm gonna put open dot or open circle on 2. What numbers are x's less than 2? What numbers are x's less than 2? What numbers will x's be less than 2? Mason, which direction? Right or left of 2? Left. I believe you're correct. Let's go left. There we go. Okay? So if I put in, let's see, 3 times 0. See, pick a number for x. Pick a number for x. It can be anything on this side, right? It can even be negative 10. Even though it's not here, can it be negative 10? Yes. Yes. Can it be negative 50? Yes. Yeah. Negative 100? Yes. Yeah. Is 3 times negative 100, what is that? Negative 300, right? Is negative 300 less than 6? Yes. Yes. If I put a 3 in here, 3 times 3 is 9. Is 9 less than 6? No. So that's why this side doesn't have any values that's going to work for this. Does that make sense? Okay. All right. How did you solve the inequalities above? We treated each one. Let's see. Each inequality. Oops. I don't know how to spell each apparently. Each inequality as an equation to isolate what? The variable. Okay. How is solving an inequality like solving an equation? Nathan?
You just have to replace the. I forgot.
Inequality?
Yeah, you have to replace the inequality with like an.
But how is it like solving an equation? How is it similar to it?
You have to, or for both, you have to isolate a variable.
Isolate the variable by?
Inverse operation.
You got it. They're similar because you isolate the variable by using, what was that keyword that we were just saying? Yeah, inverse operation. Okay. Any questions? You want to try the next part on your own with your teams?
Yes.
And then we'll go over it as a class in about 3 minutes. 1 minute per problem. Yeah? Okay, 3 minutes. Try it out. Don't just sit there. I want you to work it out. Here we go. So, 2x plus 6 is less than 0. It's less than 0. So, what's my very first step? Is that Stella? Is Stella? Right there. Okay, Stella, go for it. Which one? Number 10. You got it. Take away 6 on both sides. Perfect. If you're ever unsure, because I had people doing this all day on their test, make sure you're crossing the equal sign or the inequality sign. Don't go to the same side, okay? Go on. Divide 2x on where? Both sides. Thank you. And x is going to be less than -3. So here it is. -3. Open or close circle? Open. What numbers are x is less than -3? To the right or to the left? Left. Okay. Do you guys get confused with those names? If you do get confused with the inequality signs, this is what I used to tell my 6th and 7th graders once upon a time when I was teaching them. Watch this. X is always on the left. Always put X on the left. This is less than. Do you see the L? And then this is greater than. Okay? So if you ever get confused, as long as X is on the left, you can read it just like that. Okay? If X is on the right, you have to read it backwards. Is it opening towards it or is it opening away from it? Okay? But if X is on the left, you can always read it like this. X is less than or X is greater than. Do you see the less than sign as L and hook for the G for greater than? Okay? All right. Next one. Who wants to try it? Stella, you want to pick someone? Happy belated birthday. Or is it today? Happy birthday.
Can we also say happy birthday in another class?
There's another person whose birthday's today.
Mason.
Mason? Is it Mason? No, not this Mason. Okay. Tyler.
Oh,
It's you, bud.
okay. We're gonna distribute the 5 extra parentheses.
So I've been telling my students we should go backwards on PEMDAS when we're solving for x. Can I divide both sides by 5 first? Absolutely. Would that be easier for you? If it's not easier for you, then go ahead and distribute to get rid of the grouping first, like so. But I'm going to tell you, if you do the dividing first, you still get the same answer as if you distribute it first. Okay, so I'll show you that way after. But if you distribute, tell me if this is right.
Why is the 3 still a 3?
I don't know.
Multiplied by 5.
You're right. Then why are people forgetting to multiply that on their test? I'm just saying. We're definitely more than 6 or 7 people on that one. Yeah, that happened. All right, here we go. 5x minus 15 is greater than or equal to -5. What do I do next, Tyler?
We're gonna balance out the equation.
How so?
We're gonna add 15 to the 15 and add 15
Wait,
to the
what? 15 to the 15?
Yes. -15.
Okay. So I'm going to add 15 to the left side and
15 to the -5.
oh, I almost added to my 5x. Thanks for telling me exactly which side to add it to. So we have 5x is greater than or equal to 20, right? 10. Positive or negative? Good job. Now what?
We're gonna divide 10 by 5.
I just have a question before I turn in. Do I have to check these to get a 10? Check the answer?
Yes, you would have to check them to get a 10, but you don't have to. Still, 9.5 is an A. 10 is an A. Either one is an A. Okay, thanks. I'll grade it as soon as I can. Here we go. We're gonna divide. Last step is to what?
We're gonna divide the 10.
Are you sure not subtract 5?
No.
Really sure? I hope you're sure.
I'm very sure that it's division.
All right. Okay. Is it open or closed circle? That means closed. On 2. Now what? Jordan. Which side do I shade, dude? Left side or right side? You said both. Last time I checked, there's only one Jordan in this class. Come on, Jordan. Can you read that inequality out loud for me? This one. Can you read that out loud for me? Yep. So don't lean on your caster chairs. You're going to fall over. Okay. So which side is greater than or equal to 2? Right or left? Right side. Was that like sweat-inducing, nerve-wracking moment there for you? Dude, that was only an inequality. It's not going to eat you up alive. All right, here we go. Last one. Okay, I forgot. I was going to show you. What if you divide it by 5 first? Right? That parentheses will go away because I won't need them anymore. Right? And then I would add 3 to both sides and get x is greater than or equal to 2. Isn't that the same? Like I said, it doesn't matter. Okay, what's up?
I have a theory.
Please.
So like, we can determine which way the arrows point, not from like the greater than or whatever. We'll, like look right here, you can see like the.
Yeah, so people do that, and then this is what happens. You end up with something that's backwards. So what are you gonna do? Are you gonna go to the left? X should always be on the left, and that theory would work. That trick would work. But if x is on the opposite side, if the inequality is fine, but then the variable's on the wrong side, it's going to be the opposite direction. Does that make sense? So you need to make sure you're reading it correctly. You always read from x first. X is greater than 2. You have to read it that way. When you read it out loud, you know which side to shade. Okay? So try to train your brain to read the inequality out loud, okay? All right, here we go. Next one. I'm going to fly through this one. Who wants to do it real quick, or do you want me to just do it? Brian's dying to do it.
Oh, okay. So first multiply the fraction by 2 and the 7 by 2.
All right. Now what?
You get x plus 10 is greater than 14.
Okay.
And then you subtract 10 from the positive 10 and the 14. And then you have your answer.
Okay. Open or close circle, Christian Vuong? Open. So I'm going to put open circle on -4 or +4? +4. Which side should I shade, Nathan?
Which part should we shade?
Mm-hmm.
The right,
To the right. Because, how do we read this?
x is greater than 4.
Good job. All right. Any questions? How do we check if we did this correctly? Take a number from any of the shaded side. Like, let's say I take a 10, right? 10 plus 10 is 20. Now, do I put it into the middle of this problem, or do I put it into the original? Why are we putting into the middle of your work in the test? I'm dying in my head right now. Do you know how many times I was screaming in my head? A lot. A lot, a lot. Okay, so we go back to the original and we put in 10 for x. Add 10, divide by 2. That's 20. Divide by 2 is 10. Is 10 greater than 7? Yes, make sure you go back to the original. Okay? All right, here we go. Summarize what you just learned about the symbols. Summarize, that's you. You got to do it. Summarize what you learned about the symbols. What does this mean? What does that mean? What does this mean? What does that mean? Okay? While you summarize, I will grade Brooklyn's test. Wrote about the first set of signs. First set of signs. Go for it, Gavin.
When there are no equal signs, you use an open circle to indicate that the number one is not included.
Okay, these have no equal signs. So I'm going to put this little 3 triangular dots. Do you guys know what that means? It means therefore. It's a shorthand for therefore. So we use open circle or dot on the number line, right? Open. Okay? What about less than or equal to or greater than or equal to? Let's see. Jordan, you want to pick someone?
Oh, yeah, that's fine. Okay, you can do closed circles and open circles.
Why?
Circle one for each one.
Why?
Because the one without the line under it,
Without or with?
without the line under it is open. And then the one with like the line has the closed.
What do these lines represent?
Equal to. It's like half of it is equal to, and then half of it is the other one. So you can see that they're so that it's
Right?
both at half.
So we include or exclude the number? Include or exclude?
We include because of the line under it.
Mm-hmm.
Same.
By using, like you said, closed circle. Yeah? What if it was just x equals 2? What would you do on the number line? Hiba. On the number line, would we have a whole section covered? Nope. Just on 2, nowhere else. And the opposite, what if it was x is not equal to 2? How would you graph that?
Everything
So how do we do that?
like 2 dots on one and 3 maybe, or just put dots on everything.
Open circle on 2, because that's the one spot we don't have any answers, and we would shade both directions. Interesting, right? If you ask an Algebra 2 student, half of them won't be able to answer that for you. I still need to talk to them about it. All right, here we go. Inequality with negatives. Woohoo! All right. Using the number 3 and 5, perform each operation in the tables below. Then choose the correct sign to compare the new values. If I add 12 to 3, what do I get? And 12 to 5, what do I get? So which one's greater or less than? 17 is greater, yeah? So I should try to eat that one. The alligator should be facing that one opening, right? Is it equal to? They're not the same. We can't put an equal sign if it's not the same. All right? What if, well, let's just look at this. 3 and 5. Which one's bigger? 5 is bigger, right? So naturally, it would be like that. If we multiply by -2 for 3, what do we get? -6. What if I multiply 5 by -2? Negative 10. Is negative 10 still greater or smaller than negative 6? All right, so we got to make sure that you guys notice that. Did you see what happened when we multiply by a negative number? But if I subtract, will it be the same or different? It's naturally like this, right? 3 is less than 5. Let's subtract 7. 3 minus 7 is? 5 minus 7 is? Okay, which one's greater? Negative 2 is still greater. So the sign hasn't changed, right? Okay, let's add negative 10. 3 plus negative 10. Negative 7. 5 plus negative 10. Negative 5. Which one's bigger? Negative 5. So 5 side is still greater for this situation. All right, let's try this one. Multiply by 4. 3 times 4. 12. 5 times 4. 20. Which one's bigger? 20. Did the sign change? No. Let's try dividing by 1. Negative 1. 3 divided by negative 1. Negative 3. 5 divided by negative 1. Negative 5. Which one's greater? Oh, what? When did the inequality sign change directions? When did the inequality sign change directions? Right. Multiply by a negative or divide by a negative. Okay? It always, always, always is the rule. That's a rule that is always true. It's a law. Okay? When we multiply or divide by a negative number, the inequality sign change directions. Okay? I want you to work together to circle the statements that are true and mark through the false ones. So meaning mark through, like cross out what makes it false. Does that make sense? Yes? Okay. All right, circle the statements that are true. A, adding a negative changes the direction of inequality sign. No, not adding, but rather, I don't know. We'll see. B, multiplying changes the direction of an inequality sign. Does it? No, not necessarily. Multiplying by a negative changes the direction of the inequality sign. Yes. Yay! It's a circle. Okay. Dividing by a negative changes the direction of an inequality sign. Yes. Subtracting a negative changes the direction of the inequality sign. No. No. And no. Okay. Need to know number 1. Can you write a rule for when inequality sign changes directions? Be specific. Go ahead and write a rule. Make it yours so you remember. You can make the words yours. Okay? It shouldn't be mine, because if I keep telling you mine, because it doesn't stick. You have to write yours. Write your own. Okay? Need to know number 1. Fill it out. It's best if you write your own. You're doing this right now. Okay? If you think you have a really good rule, you can share it with me. I'm happy to. It's up to you. Just make it yours. So you understand it best.
There's a negative switch, so I just add an 80 to 10 position. Make sure that's the ring doing. You should maybe specify that.
Anybody want to share theirs? No? You all got your own? No? You don't have your own? Then let's share. If you have one that you think other people could use, share. What you got? Nobody? Maddie? You want to try? Say again? Multiply or divide by a number?
Multiply by -13.
Are you giving an example?
I don't understand exactly, but I mean, I
Write a rule. Just a statement.
or like multiply or divide by
Yeah, you don't have to overthink it. Just tell me what you're supposed to remember so you don't forget it.
multiplying or dividing by a negative, and it's probably going to change inside.
Probably or for sure? Yeah. You change the direction of the inequality sign. If you don't have your own, there you go. Is that okay? Better? Okay. This rule is true when variables are involved as well. Solve the following inequalities, keeping your rule in mind. Shade the solutions. So go ahead and try it. I will pause for about, should I give you guys 5 minutes or 3? 3. Done. Yep. You're going to get back. Here we go. Number 1. Who's got number 1 done? Number 1. Nobody? Come on, I saw people. William, tell me, what'd you do?
Subtract 5 on both sides,
Good.
and then you divide it by -3 on both sides.
Ooh, tricky. So if I divide by -3 on both sides, what happens to our sign that was already at greater than? It flips, switches direction. Here we go, open. And x's that are greater or less than -4? Which one is it? Less. So we're going this direction. Check your answers. Make sure you shade it correctly. You got it? Okay. All right. Here we go. First step. Janice. I have to switch the sign already? I didn't do anything to make the switch signs. Have I? You can't just anticipate it and change the sign because you might switch it back to its original. So don't do it until you actually multiply or divide by a negative, okay? So we're gonna subtract 2 here, and we end up getting 24 is less than or equal to negative 8x, right? Sorry, the other way. 24 is greater than or equal to negative 8x. So we divide both sides by negative 8, not negative 8x. We're dividing by negative 8. Then we get x is equal to, or x is less than or equal to, or greater than or equal to, negative 3. Which way? Sit up, please. Maddie.
X is more than greater or equal to.
More than or equal to negative 3. This should be what's graphed here. Here's negative 3. Open or closed?
Closed.
Closed. X's that are greater than is to the right. Try to stretch to the edge of the grid, edge of your number lines. Try to stretch all the way to the edge. Okay? Questions? No questions? Ooh, this is a tricky one. Let's see if anybody caught the tricky one. Here we go. Ready? First step. Brian.
Multiply both sides by 6.
Multiply this side by 6, this side by 6. What did I multiply by? 6. Is that a positive or negative number? Okay, just checking. S minus 14 is less than negative 12. Now what? Ready? Add 14 to both sides. Done. Then I have x is less than 2. Is it less than 2? Raise your hand if you got x is less than 2. Raise your hand if you switched the sign and said x is greater than 2. Raise your hand if you didn't do it. Why? Why not? This one does not change directions. Why? Because it multiplied by positive 6, not negative 6, right? So here's 2, open or closed? Open, and it's all the numbers to the right or left? Left. Okay? Are we good? Questions? Comments? Thoughts? Yes. Because sometimes my pencil doesn't necessarily show which side I'm shading. So to show Mrs. Byun, I really wanted this side to be shaded. Sometimes I have my students do that just so that it's super obvious. That's all. But don't scribble over the circle so I know it's open, not closed. Yeah? Great question. Anyone else? Cool. All right, check your work. Here we go. Choose a value that's a solution and substitute it for the variable in the original inequality. You guys, why are we constantly going back to like middle of your work? I told you not to do that. You guys keep doing it on your test. You're killing me. All right, so make sure you go back to the original. Let's pick a number. What's a number that is less than negative 4? Negative 5. So let's do negative 3 times negative 5 plus 5. Should I use the greater than inequality or less than inequality? Greater, because we got to go back to the original inequality. Get it? Yes? Okay. So positive 15 plus 5. Is that greater than 17? Yes, it is. 20 is greater than 17, so we can move on. Next one. What's a number that is greater than -3. How about 0? Woo. I like 0. Don't you like 0? Anything you multiply with 0, what do you get? That's why I like 0, don't you? If I can use a 0, I would use the 0 all day. 4 times 0 is 0. Minus 1 is -1. -1 times -4 is? Sorry, -1 times -2 is? 2. Is 2 less than or equal to 26? Yes, it works. Do you see? If I use this, do you think that would be right or wrong? It would be actually right, but you know, who knows? You might have made a mistake somewhere. I wouldn't go with that. Okay. Here we go. What numbers are less than 2? 0. Remember, 0? If you can use a 0, use the 0. 0? Or do you want to use 2? 0? Or negative? How about -4? Do you know why I chose -4? -4 minus 14 is? -20, right? What is it? I worry for you guys. Divide by 6, what do you get? Because I get a whole number, I wanted to find an x value that's going to get me the whole number. So I was trying to think ahead, okay? So is this number greater or less than -2? Is this number greater or less than -2? Less than. That's true, so we're good. How is inequality, solving inequality different than solving an equation? How many answers do we have? We have many more solutions from one inequality than an equation. Equation has how many? One or none or infinitely many on both directions, right? But inequality is much more than just one solution. It's either one half of the solution or the other half, right? Okay. What else? We have to do what? Inverse operation is the same. What's different though? We're looking for something that's different.
You have to flip the inequality sign if you want to divide by negative.
We have to flip the inequality sign when we multiply only or divide too? By a negative number. I was trying to squeeze it in, so I ended up writing it on top and bottom. All right. How we do? We're okay? Let's see. Should I give this to you now? Should I give you the test now?